number 15, which is the integral of dx over the square root of x squared minus 9. And we expect x has to be equal to 3 secant of theta. Therefore, dx is going to be equal to 3 secant theta tangent theta. X squared is going to be equal to 9 secant squared theta. And if we have 9 secant squared theta minus 9, this has to equal 9 tangent squared theta in the denominator. So when I write this out, I'm going to then imagine I've already replaced that radicand with the 9 squared tangent squared theta. And we get integral. Numerator is going to be this 3 secant theta tangent theta d theta. And the denominator will just be the radical of the 9 tangent squared theta. That gives you 3 tangent theta. And so the tangents cancel out, the 3's cancel out. We only have the integral of secant of theta d theta. And if we remember back from our previous lesson, what is the integral of secant? Well, the idea here is you have to multiply both the numerator, which is the secant, over the denominator 1, by the phrase secant theta plus tangent theta. And so with this, we can then do a u substitution is equal to the denominator secant theta plus tangent theta. And surprisingly, when we do our du, we're going to get secant theta tangent theta for the first term. Derivative of secant is secant tangent. And the derivative of tangent is going to be secant squared theta, which is going to be this entire numerator. So we have the integral of 1 over u du. And this is going to be equal to the natural log of u plus c. And doing our reverse substitutions, this is going to be natural log of secant of theta plus tangent of theta plus c. And what we see is that, okay, originally we had x is equal to 3 secant of 3. X is equal to 3 secant of theta. Secant of theta is going to be x over 3. 1 over cosine of theta is going to be x over 3, in which case cosine of theta is going to be 3 over x. So in our quadrant triangle, if this is theta, 3x, so therefore this has to be x squared minus 3 under the radical. And so I want the secant of this, so if I were to write it as the natural log of secant of theta. So what would secant of theta be? So if cosine is adjacent over hypotenuse, then secant will be x over 3. And we're going to add this with the tangent. The tangent is going to be opposite of adjacent, so square root of x squared minus 3 all over 3 plus c. That is going to be my answer. And there you have the main lesson of this section, such that whenever you have these three terms, you have either the square root of a squared minus x squared, you have the square root of a squared plus x squared, or you have the square root of x squared minus a squared. The idea is for the first one, x is going to be equal to a sine of theta as a substitution. The second one, x is going to be a tangent of theta. And finally, x is going to be a secant of theta for these. So for your assignment, why don't you try one of each of these problems? The first one that we will have for this case is, let's do 21, which is the integral. Now, let's not do the limits of 5x cubed square root of 1 minus x squared dx. For the second case, when you have those added together, let's do number 12. Number 12 is going to be square root of 1 plus t squared all over t dt. And for the third case, let's do number 3. Number 3 is going to be x squared over square root of 16 minus x squared dx. All right?